Video. Hello.
Okay. Hello.
Am I audible?
Yes, you're audible, Anand.
Hi, myself, architect Anand. So I've been practicing for the last 12 years. So right from the day I actually completed my bachelor's in architecture, I had this idea of at some point I have to do a master's degree. So I was a little confused on what exactly I will do. I had all these ideas about sustainable architecture, urban design, digital architecture. So all these ideas were running through my mind. So initially I decided, okay, 5 year down the line is the time that I should be doing my masters. But by during my practice, I realized that I was actually touching upon a lot of these areas, like a little bit of sustainability, a little bit of urban design. So I was unable to figure out exactly what my interest is, my exact interest is. That is when it actually, the entire time of 5 year actually became 12 years. It is at that point that I realized that I saw this opportunity wherein Asadi was bringing up a curriculum where it is actually a combination of all these small interests that I had. So going through the curriculum, everything what interested was that it's more like a crash course, like where you get the bits and pieces of all these things, and what is my interest, I can figure out and I can put my focus onto it. So rather than presenting our individual works, we will be just rushing through certain projects that we have done and what kind of experiences that we have undergone. So we had these computational architecture bit, which came up in the second semester, wherein where we learned a lot on Rhino, Grasshopper, all these new tools that was very alien to us. So our first semester project was basically to design a primary health center with to be a sustainable because of the focus was on to sustainable architecture. So in that semester where we got to learn about a software known as Design Builder, wherein you actually virtually create the building or in the software and try simulating that the building, how amount of daylighting we are able to receive inside the building, and how the material responds to the climate, and how by changing each material we will be able to control the indoor temperature. So that was the things what we handled in the first semester. In the second semester, it was more about designing the Cochin Muziris Binale Pavilion, which should be, which were in our design brief, we were given to design recyclable, disassembled. In that semester, we focused on computational design and parametric tools, wherein we were able to play with our form, try out different combinations in our parametric, like in our Rhino and Grasshopper tools. So these are certain imageries of what we have done, certain bits and pieces of the works that we have done. I am handing over to Basil. He'll be presenting the rest.
So hi, am I audible as me? Hello.
Yes, Basil, carry on. You're audible.
Okay. So hi, myself Basil Paul, architect Basil Paul. I have been practicing for 3 years at Eminence Eminence Architects. Coming on to my first SM project, like as you can see here, the massing. So we were focusing on the sustainability as concept. So my concept to the UPHC was biophilic design. So biophilic design, which means that the patient-centric design. So creating a connectivity through nature and the patients. So here we can see that the daylighting analysis, where we used this parametric or this criteria for the UPHC design, and as well as in this project we aligned with the IGBC criteria. As you can see here, the connectivity to nature, healing spaces towards inpatient areas and treatment rooms, and as well as the air quality monitoring and testing. So this is the second semester project, which was a Binale Pavilion, focusing on the disassembly and as well as the using with the sustainable materials. So as you can see here, the materials were thatch, bamboo, and seed embedded panels, and the timber paneling. So for the parametric area, I have used the grasshopper twisting panels, where the visitors can go through and they can enjoy the twisting panels. And these are the grasshopper scripts. Coming on to the incident radiation analysis, where the site is day lit or not. So my roof was red in color. So where I have provided the Warmite panel system as the parametric design. So I have provided that, and my concept was in biomimicry, which was concept from leaf to the pavilion as it is. So as you can see here, right on the right side, which is prototyping and fabrication, the roof I have divided into 17 panels, where placed on the seed embedded panels. That's it. So this is the one of our students' work. As you can see here, the echo chart for the site analysis, and we have used the daylight and ventilation strategies for the design. So for the IGBC criteria, we have used the comfort analysis and CFD, computational fluid dynamics, and daylight strategies, and water demand and the power demand. Now I am handing over to Lizette.
Yeah, so myself, Nitin. I'm a recent graduate from BR from ASAD itself. I joined the M.Arch program immediately within the span of 1 month. So it was a huge, stepping up with respect to my classmates who are much more senior to me. But yeah, with respect to the projects that we have started off in the first semester, we dealt with the urban primary health center. So we used, simulation softwares like Autodesk Insight as well as Design Builder to simulate the existing conditions with respect to climate, to the temperature, to the precipitation, as well as the design development based on a sustainable aspect. So in terms of sustainability, of course, we have to look upon the carbon neutrality of the building, the solar panel, the amount of solar panels that can be achieved in the building. So all these analysis we have derived from the simulations that we have done. Now carrying over to the second semester, it was a integration of sustainable practice within the domain of parametric tools. So now we came upon new tools like Rhino and Grasshopper. We had to design starting from geometrical aspects of the design. So even starting from the zoning aspects, the parameters are set based on the constraints. So this is how the conceptual development is even made through the idea of trying to develop a framework. So the design is not just lines and curves, but trying to make the design based on these inputs that we have provided. And then the design is given to us. Then the iterations are carried forward throughout the entire process. So the entire structure has been developed based on the Rhino and Grasshopper, as well as tools like simulation tools within Grasshopper, like Honeybee and Ladybug, to simulate the temperature required. So here I used a double skin roofing system for my Kochi Binale Pavilion, where the idea of simulation gave a real throwback to how architecture can be developed using these tools. As well as fabrication aspects were made with respect to 3D printing modeling. Now, this is another of our classmates' work, Mr. Srikanth. So he has developed the the primary health center based on aspects from the Grasshopper as well as AutoCAD. Now, with respect to that, thermal analysis was also created, as well as the truss system was also developed within Grasshopper. This was a recent project where we had to develop the facade for our institution, ASADI. So it had to be a combination of facade plus students pavilion for the with respect to the smart materials integration. Yeah. So I carry forward to Azmi for the rest of the presentation.
Just stay online to put it to the next slide. Okay. So this was our first project. It was a primary health center. And basically sustainability was the main focus. So in fact, when I came down itself, we had actually gone for the IGBC convention. We had met with the president and we really collected a lot of data and we had a good view on before we started the project itself. And basically the 4 things that we really looked into was, hello? Yes, so the 4 things that we looked into was the thermal comfort, the daylighting, IGBC rules and regulations like the healing, the water systems, the sewage systems, and basically all of it. Can you please go to the next slide? Yes, so this was our second project and it was a pavilion, and the project was Cochin Binale Pavilion, and we had a process in which the whole thing was to be looked into with a literature study, then a live case study. We had to make inferences on it, then get into understanding the site, which was the Cabral Yard in Fort Kochi, because it has a historical context. And soon after which, please go to the next slide, please. Next slide. Yes. So then we had to just put the previous slide, please. The previous slide to it. So yes. So this was the site analysis. So the site, again, if you can look, we had put in the parametrics. Ladybug was used to do a site analysis, and then after which we worked on our concept. And the concept which I had taken up was of a millipede. So you can just see how we kind of integrated biomimicry, and to make the form, I had to go into, please, next slide, please. Yes, so the previous one. The previous one. Yes, this one. So this in which the parametric, so we basically made basic form of the millipede is, I mean, I took that as the basic concept, and I had those shell structures to be made, 9 panels to be made, and all these 9 panels were scripted using Grasshopper. And the good thing about this parametric design is that you have the flexibility, unlike SketchUp, to move all the panels in whichever direction you want, orient the building in the right position that you want. So you have scripts which will enable us to even find the positioning of the building on site. So we had used something like Galapos. Then also for form find and form, that is to get a basic form instead of going to a structural engineer. I did go to a structural engineer and get the basic form, how it is done conventionally. But then with something like a lunchbox, we have a curve to curve a way of doing it in Grasshopper, and you can actually get the form. Can you go to the next slide, please? So these are some rendered in images which I did in Enscape after the whole form has been done. So this was basically, it is a pavilion which can be disassembled. So it was to be made with sustainable materials. So jute was basically looked into. So we did have to do a little bit of research study on the material aspects of it. Next slide. Yeah, so this was basically the master plan of the site of the Cochin Denali Pavilion project. So that brings us to the end of our presentation of the students. We have a few minutes. If anybody wants to ask any of us questions, we can. But otherwise, we'll have to wait a little bit. I will just check if the next session is actually tuned up for 2:30. I'll just get back to you in a minute. Okay, our next session is on parametric design and architecture, parametric design and architecture. So this is a technical session which is going to be uh, put forward by Yokes Marapa. So we are privileged to have Yokes here. Yokes Marapa is a trailblazer in the world of parametric design and digital fabrication. As an official 3D trainer in India and founder of YAF Designs, he bridges creativity and computation to craft innovative solutions from adaptive facades to wearable architecture. With a rare blend of technical mastery and design imagination, Yokes has mentored hundreds of students, empowered educators, and collaborated with leading institutions and studios, namely IIT Kharagpur, VIT Vellore, and Azadi College. His expertise span from Grasshopper and Rhino, data-driven design, sensor integration, and advanced workflow like Rhino, making him a sought-after guide for the next generation of architects and designers. I humbly invite you to the program, sir.
Hi guys, this is Yokesh. Yeah, am I audible?
Yes, sir. Carry on.
Yes. So it's good to see all of you back. So there are some new faces also. Okay. We'll just see. I'll just give you an introduction about myself first. So I'm basically an architect. I graduated from Geetham School of Architecture in Vizag. Then I was practicing my like any other conventional architecture. I was practicing my architecture field. Like we had a set of rules, and then we were totally into hospitality designs. And then I was practicing in my home native town only. But there was a unique project which came, which was to design the interiors for Vande Bharat. So I had an opportunity personally. I had a mentor, so then I went in the guidance of them. So when I was supposed to design for interiors for Vande Bharat, so we not only have it's not you design and leave it. I have to sit for the manufacturer, and then I have to make drawings, especially for it's more like going into sort of automobile design. Still, you're being an architect, and then you're taking the responsibility of an architect also. So you have to sit through the manufacturing process. We have to regulate what everything is happening, and then I have to make drawings especially for the machines, and I have to make drawings and models which has to be fabricated, and then the assembly drawings, everything have to take in care. So you're sort of in a position where you're the connecting part of the design, manufacturing, and assembling, everything. The whole production unit also depends upon when it comes to architecture. So you don't. That's what when in our typical construction or something, we are responsible in a very larger scale. but each design is unique for us. Every residence is unique for us. Every mixed use, whatever buildings we are doing is very unique for us. But what if there is a case, something like, let's say, just for this automobile case, you create a single module, but that module is going to be repeated in some thousands and thousands of pieces. So you have to break down each part, each module individually, and then it has to be in a very larger scale. And then it has to go, it has to work in any sort of with any sort of parameters also. We'll see how things works also. So after my Vande Bharat design, so I became an authorized Rhino trainer also. So so slowly I developed engaging with colleges, and then I started taking works from being a computational designer only. So when you're working with an architecture, a typical architectural firm, the system will be a different part. But when you're working in a very larger scale, the role of computational designer is very crucial. So we'll go with I'll just share my screen. Maybe I have some few presentations. So our master students, they are, I guess, familiar with these presentations, but we'll just go through it. Okay. Okay. So we'll go with what is actually something called what is parametric design and how is it formed and everything. It's not a totally modern concept called parametric design. People used to people were already following parametric designs. Maybe it wasn't named such as parametric design. If you take Anthony Gaudi's designs, there was no softwares in his times and all. So if you see all those totally organic chains, where only he can make all those things. It wasn't, suppose someone cannot in the current trend or something, you cannot recreate something like that without recording in a very bigger scale. So even if you ask someone to recreate something like that in within the time period of with the modern generation, it takes really lot of time. But his time, the times were different. In Gaudi's period, maybe in his whole lifetime, he was working with only 3 or 4 projects. But in our scale, every architect in a very bigger scale, they work 3 to 4 projects, at a year or something. So the time span of every project is, the design period of every project is less, but the time of construction will take a lot. So when you're working with very large scale projects, you have to record each design. So every design has to be recorded, and then it has to be recreated also. So that part is where you need to where parametric design goes. So that's what, like I said, it's not a newer term. Since there wasn't already a community, it wasn't actually given name. That's all. So Patrick Schumacher, who coined the name called parametrism, like he's one of the partners of Zagadit, and he actually he recognized the community, and then he gave the name as we have a community, and then we have to put forward to it, make it visible for everybody, something like that. And that's where parametric design is something is being born. So we'll see how it has been traditionally made. So we have our conventional type of designing, and then a parametric way of thinking. So what is our conventional way? We get our design problem, we make all our site analysis, gather our literature studies, case studies. Then once everything is done, we go for standards and everything. We get the design problem, and then we work with the conceptuals, make some 2 or 3 iterations of the same module, design concepts. And then when everything is approved, then we go for the approval drawings and everything. Then it's when the drawings are done, we'll go for the construction part. But when it comes for parametric thinking, so the amount of data you're getting, it's always, it's more like a variable sort of. Maybe the same amount of temperature you record in a single day is not the same in the other day. Maybe in the summers you record a lot of radiation, and in the winters you record very less radiation but more wind sort. So for a single year there will be a lot of change. It's not static, we can say. So we have a choice sort of. So either you can have an optimized solution for everything, maybe a single solution, or you can have a variable solution. Maybe for a first 6 months, the window will be somewhat in this facing direction. The other 6 months, the window will be facing this sort of direction. So we can analyze everything at live, and then all the algorithms can be made with the whatever design process we are making can relate all those studies which you already made. So you make iterations with the relation to our studies. And then you can go through your design process. So once the design process is done, then again, if you want to change anything, since all you have already updated everything in a a script-based form, maybe a coding-based form. So you don't have to go in a manual sort of a traditional way of working in drawings. So you work in a model-based system. Then you just update the drawings accordingly. You don't have to rework everything entirely. You can just take everything part by part and work it easy in a very easier form. Maybe the time taking will be the same. Let's say if it takes to create some 5 to 6 iterations of a traditional conventional type, let's say it takes you to some 2 to 3 months. Parametric work will also will give you roughly take you to the same amount of time. Let's say you make a script for 2 to 3 months, but the amount of iterations you get will be n number of times. When you can create 3 to 4 designs in 2 to 3 months, you can create thousands and thousands of iterations in the same month. When you just need to make a single script properly, that's all. And what are the different types we can say? There is constraint-based, propagation-based, and generative-based. Constraint-based is our typical sort of conventional style, and propagation-based is something where we use parametric tools like Grasshopper or any Dynamo from some parametric tools to support our design workflow. And generative system is like when you go towards your AI field something. So you give all your parameters to the system, and then you give all the data, parameters, and everything, and then you ask system to give you the optimized solution. So you give the parameters, and then the system analyzes with its own machine language, and then they have their own neural system. So it's not like they have their own. We have to train them. So there are some different systems helping this sort of generative systems. So we train the system first, and then for that system we'll give all this. So once it is done, you can get all those generative forms and all. And what are the tools now? Is basically it depends upon the market. So every system has their own tools. Every company has their own form of parametric designs, and we can say McNeil has Rhino and Grasshopper, NS has Cataya, Autodesk has Revit and Dynamos, and Blender also has some parametric works. Houdini has some parametric works. Fusion 360 has. So every company started to adopt parametric work since it breaks the our regular conventional form of designing, and then gives more flexibility for the designers to rework their design, reimagine their forms. So using the same traditional construction methods or fabrication techniques, what if you can go for another step? Since the fabrication industry has been grown a lot, you can make any type of organic shapes and all. So there are many different tools have been formed. Next. So where they are using a lot means the current technique is morely when you're going with parametric forms. It's widely used in facades. So right now it's not restricted to facades. There are many forms also. We'll see all those things. How parametrism is being used in every disciplines in architecture. So if you are into just in fabrication, how parametrism is used, how digital architecture changes itself, and then if you're into sustainability, how they are using it. So each one of the each disciplines will see. So why it has been and what are the fields? Let's say it's been used a lot. So by default, not default, we can say any type of design-oriented fields we can see, the parametric logic and all. So architecture and design, it's almost everything is same. So design means you're not restricted for just that's what interior designs, all those things. Even when you're going for automobile designers, navy-based designers, or any type of footwear designers, all those types of designers can be they started adopting this parametric forms. So why it has been largely used is the number of iterations you're going to make. So, but that's all. Any typical sort of conventional style, you can make maybe some 10 to 20 maybe. So what if the number of iterations can increase your productivity also. So as well it increases your productivity, then as you're increasing the iteration style, you're automatically generating your drawings also. So it goes with customization and optimization, both of. Next, product designers uses how in fashion all the which is associated with design fields, you can see all parametric forms. So you can see here there's a facade image is being used, and artistic images, all those reason, the iPhone, the Apple Watches bands and all. If you see all those, you can see all those textures and all. So every textures you see, every automobile industry, even if you see the newer versions of EV cars, the BMW, MG cars and all, case plate, everything. So they are being made into a more futuristic forms, where you can see parametric works and all. And for example, who uses maybe is being who's using in the industry, we can see for architecture, Zahad is one of the pioneer names, but these are all the people who are who has their own form of creation. Many people will have their own style, so they created their own style. That's all. And why using parametric design is being is not it's different, or it gives you an advantage about what gives you an advantage effect on for making a conventional style. So any form you're breaking down every form into codes digitally. So what we do is, so just like how we are going to let's say you're making any forms in SketchUp or anything. So you first make the drawings, and then you make the 3D model, and then you apply the textures and materials. You design it accordingly, and then you present it. So if you're going with same techniques only, what we are doing is you're creating a digital twin basically. Then before you're going for any construction technique form of your real-time construction, you create a digital twin, and then you prepare yourself. You quantify it. So what if the quantification? When you are able to quantify it, you can give more mathematical evidence. That's all. So let's say when you're going for, that's what it's more like a tool-based system. So if you're using any SketchUp or anything, it's not like you can't do follow parametric design in any other softwares. It's considerably, the learning curve is steeper, but once you get a hang of it, it will be more useful. That's all. So let's just say, assume you're using Grasshopper or something, and you're making a building something, or a hazard system, or any type of building system associated with some parametric forms or something. So you're having some different types of materials. You're having different types of rooms, or their spaces are there. How they react to each and every other. So let's say how much of radiation you're getting inside the buildings, how much of sunlight hours it is getting, how the wind effect, how the wind is flowing inside. So all those effects can be, can be updated at live when you're working with parametric designs, and then how each forms changes affects those external factors also. So all these parameters can be controlled, and then you can design, you can give an optimized solutions. So not only it gives you more organic forms, or unimaginable forms, they also make you a new style of thinking. That's all. And again, you're not restricted to construction techniques, or whatever typical sort of construction techniques. These are all forms, and any you can make any type of designers can adopt Grasshopper or anything, Rhino or Grasshopper, and then they can fabricate their own styles. That's all. So if you can see a glove which has been made entirely through parametric design, and then this whole mold is, first they make the mold 3D printed, and then they make a silicon mold of it. That's all. A silicon mold is made, then it has been fabricated, injection mold, and even you can make some variables or whatever using a Rhino and Grasshopper. So what basically this is, you have to make logics. You have to find the math behind it. What is how every geometry reacts to and everything. So how it's we usually we leave our logical thinking when we cross after 11th and 12th sort of. So once we started going into too much into design part, and then we started having we started losing the connection between how every geometries are forming, how in our style we usually consider how a space feels. So our meter will be like how the emotional connect between the spaces. So what if the emotional connect is also there, but you can always give a proper mathematical value also. So in that form, parametric architecture will help you a lot. So it's basically always you design with logic, but also you bring your aesthetics part. So how you're going to use Rhino in form of our own AEC industry. Rhino is basically how it has been adopted, how well it got used to in our AEC. So architecture is more towards it was never a software based or something. It was totally dependent upon how a person feels the space, how an architect creates the space in his perspective, so how it adapts to the space sort of. So how much of emotional connect it creates, all those things. So what if you can still follow all those things, and you can make more shapes which it forms all those futuristic effects, and still give those you make all those you form all those unimaginable forms also. So all these forms can be it's not you have to know the tools and you can make all those forms. You have to understand how the logics works. You have to understand how every fabricators work, how every material works, how every fabrication techniques works. So you have to be keen about how to relate all those things. That's all. So Rhino is just basically like any other modeling tools only. So you don't it's not necessary to use Rhino. So when you're good with SketchUp, when you're using Maya, when you're using Max or something, just like any other software, Rhino is going to be the same. But what differentiates Rhino from other software is the usage of Grasshopper. Because Grasshopper, it invites more designers. It invites designers who creates their own logic. Designers every designer has their own way of designing, so they don't follow the same. Maybe the product may be the same, but process of designing won't be the same for some designer. So every designer will have different types of process, and they will have a unique way of designing. That's all. So all those design techniques can be adopted inside Grasshopper, and then it can be recreated also. So when you're going for a very larger scale, maybe that's what. It's not going to be a unique part. So if you're working for, let's say, the pavilion which you see in the screen, every hexagon has different types of fabrication technique. So maybe how all those panels reacts to each other, what kind of material it's been used, what kind of effect it creates within the space is what differentiates the normal way of designing and the parametric form. That's so in that way, how the space, what kind of quantitative effect it gives you. Yeah, it gives you what we can find using Grasshopper. That's all. Next is how these tools, we use it. So why we basically use it is like we said, when you take just to create the process of design, when you're taking some 2 to 3 months of you put your work, and then you create a very larger a code for it. So now you're able to link all those systems together, and then you are making a connection between all those systems. So you make a single, maybe a slider change or something. So every aspect related to those sliders will get changed accordingly. So it's not like you don't have to redesign everything. You just need to adjust some sliders, and then done. Your system will still work with whatever you have. Well, if there is a problem in maybe some structural problem is there, or maybe some space is going less than what is standard required, all those things, then that will start giving you an error sort of form, and everything will start happening in a real-time solutions. So whatever you're trying to make, they will all work in a very coordinated manner. So it depends upon, that's what it doesn't. For beginners, it will the learning curve is a little steeper. But once you crack this one, the amount of time you put in recreating or something, so that will drastically change, and the amount of data you're going to get from these type of geometries will also be different. So you have a large set of data, and then you can translate all those things for any type of disciplines. Let's say some structural units are there, structural engineers are working. So you're just going to send them where your structural nodes will be happening. and where your exact point loads or any different types of loads, and where you will get more loads are going. You can identify them exactly, and how your plumbing's MEPs are going. All those things you can easily identify when you work in more code-based system. And BIM and documentation. So BIM is totally quantitative based. So again, when you're working with more different disciplines, you have to be, your model should have the knowledge about how each and every industry understands also. So let's say our MVP designers doesn't require how what kind of material we use all the for our walls or everything. He just needs to know. Sorry. He just needs to know where his ducts are going to be, and he doesn't care about all of this. So he just needs to know where our AC points will be, where our electrical switches points will be happening. So he'll be working in different set of drawings. Our HVAC systems discipline will work in different system. They will work in different sort of drawing system. So there needs to be a single form where all these model has to be combined, and then each one can relate to what they are doing. So and then they have to check it also. So there is something called the quality of the model also. So they work. You can assemble everything in BIM world, maybe in a Revit or something. Then you can check whether everything is colliding or not in software called Navisworks. So building information modeling, which is BIM, you not only record what kind of material you use, you can the more detail you're adding, it's like you're adding quality to the modeling system. Even if you just add a small generator, or even if you make any light system, you can exactly mention what kind of light is being used, how many wattage of light is used, where it is being purchased, how much of what is its expired warranty period, and what if you are making what kind of regular servicing is being made or not. So you can have a proper documentation also being prepared in BIM system. So when you're working with more forms, even not only forms are important, your recording of your modeling is also important. So once you're recorded, then only that's what, you're not going to be sitting in the same single building, right? So once it is being completely recorded, then you're publishing it, or giving to the client or something. It has to be in a full complete set. So this will help you to run and maintain the building also. Next. Visualization and animation, I guess this is now fully taken over AI field. So it depends upon how good the market is still, the field is still researching everything. The experimentation is still going on. So we don't have to too much see. We can't judge how the industry is going to be maybe in a decade or something. But the design part will always be in because we are designing for human beings only. Still now, we are not designing for any robots or aliens or something. So once you start design, since we are designing for ourselves, it will be totally for human based only. So until or unless the user of the design changes, the person who designs will be a human. So you have to know where you're using your efficiency. If you're going to use your mind in designing, you can keep designing, and then you can let AI do the work for your production drawings, or all those BIM manipulations and everything. But if you want to work in production and you don't want to design or something, then you can ask for an AI to help you with all those forms. So it depends upon in what field you're picking up, and what field you're giving the data for the AI. So that is how it is being used in the industry now, and fabrications now. So why again it is being Grasshopper, Rhino, or any type of parametric software have been used for, is been preferred also. Previously, every computer, that's what the usage of robots basically. Yeah, that's what every company used to have their own sort of, generic code based system. So their robot can only work with certain softwares which they give, and then you have to train yourself to make to learn how to operate those robots. So now everything is being more, it's been made more universal. Any sort of designers can work with any sort of robots, even in a very smaller three-axis machine, milling machine, or a 3D extruders, or a 3D printers, to a multi-scale multi-axis robotic arm. The range of robots have been increased in a very larger scale. So now, what Grasshopper took an advantage over it is, you just need to know what is the basic behind it, or how the the movement of robots work and everything. So you create a module, maybe a reference about how the code is going to happen. So whatever you're building, you not only make the building, you're also helping for the production also, making drawings for construction also. So what if there is a possibility, there is no possibility for a human to sit there and work or something? So let's say in future, let's say if they are going to build something in Moon or Mars or whatever, humans can't go and build some. It will practically take some. It's not practical for our current situation. So they let robots to do all those work. So how you can communicate between robots also, you can still do everything within Rhino and Grasshopper itself. You don't have to go for many third-party user software, or you don't have to learn you can just add everything. It's just adding your skill, that's all. Upgrading to one. You don't have necessarily know how this robots exactly works. You just need to know the basics of how the robotic the arm moves and everything, and you can keep on doing whatever you're doing. That's all. So the major advantage in the fabrication industry is your Rhino and Grasshopper. Not only you make your design and production drawings, you also send models how to make everything for production for robots also. So the intermediate which acts as a skilled labor. So let's say you want to place bricks in a particular way, and you need a skilled labor, means you need to train that person for some few weeks or something, and then you have to keep a supervisor and everything, or you have to visit yourself whether the work is going on properly or not. So in those cases, you can just hire a robotic arm, and then you can, whatever design alterations you are making at live, the amount of period, let's say if a brick wall of 10 feet is going to raise in a very parametric form, it will take maybe some let's say a week or something. Whereas if you bring this robot, it can hardly do that in hours. That's all. And so it depends upon how much if the efficiency you're going to get, and how much of returns you're going to get. That's all. And so we'll just see some projects it's being used a lot, where they're using Grasshopper or any type of parametric tools. So you can see there is a studio called Differential Studio in Poland. Even the web pages, there's more unique. You can see all those crazy stuffs they do. In one of the projects, we'll just see. Yeah, Yes, this is yeah, the building. Even the website is, they have this old pixelated style, and then once you go into it, so that's what. Once you go into this parametric world, the modern form of architecture, you will start reimagining the way of your presenting it. So it's more like what kind of how much of data you're going to show. So it may look like okay, what is so different from any sort of construction with which it differentiates itself rather than this unusual sloping roof. What makes it so different? So you can see they made some thousands of iterations of the same building module. And then you can see the first layer is our area. How each and every spaces have been defined. So each and every the spaces are defined with respect to the amount of daylight enters into the building. So the form is being generated in a very that's what it's been it's a totally a generative form. Your form is generated with the amount of daylight you get into all the spaces. So every spaces you can see at live, each and every room space have been changed. Yeah, it's been tweaked a lot. It's been everything is being generated by the learning like within the software. So the amount of sunlight you get throughout the year, it calculates, and then it starts generating the room spaces accordingly. So once everything is being done, and then you are satisfied with the form, then it starts creating the form, the roof layer. So you have so it's been once the form has been fixed, they made the analysis for CFD, which is the wind analysis we made, and how much of radiation the building creates to the site, and how much of daylight you're getting inside. So once you're able to quantify, you're able to get visually okay what is happening now. It is easier to add more. Here, let's say the blue areas are your the areas which is not going to get your daylight. So here the blue areas, now you'll be adding more lights to it. So how much of lights you'll be, how much of wattage of lights you'll be needing, and you can start quantifying it now. So only these areas will never going to receive even in daylight. So I have to turn on my lights even in my daylight. So the amount of energy it's going to consume. So you can actually quantify how much of energy it's going to consume, and then you can give, okay, this will be my running cost of a building for per month or per year or something also. So you can actually calculate, you can check down to numbers, how much of actual numbers you can, this is not only going to cost you this much, how much it's going to cost to run the building also. Next. They have some few more projects also. I'll show, which is the way. Yeah, this one I guess it is just a flexible a market space where they have some 2-3 blocks or something, but all those space has been combined under a single roofing system. So they have a native Kuwait market. So what happens is the concept is being brought from the Kuwait market itself. They have, how it is being made is they'll have some small blocks, but it will be under a single big roof. That's all. So they are considered the same concept, and then they started creating a simulation. They simulated first. So you can see these triangular frames or your structural elements, and how these frames are, it's been it transfers your load system. So how these frames actually being constructed. You can see some 1, 2, 3, some 4 to 5 blocks have been very larger blocks are being made, and how these blocks, how this roofing system supports is being made. So how much of sharing system you can make, how much of energy it's been transferred, how much of load it is being transferred, everything you can actually figure it out before you're going to your construction. So even when you're not only as an architect's point of view, even when you're going for a structural view, you have to work parallel. You can't just make the form and send it to structural and then work with make it work or something. So what happens is both structural and architecture, the engineers and architects should work more parallel and make it work. That's all. So how much of radius, how much of the strength of the steel, how much of width of the steel, how much of steel width you have to use so that it supports such a bigger roof. All those things we can calculate before you're going into a construction. So again, you can see how much of the sunlight each and every room gets before. In this, every floor is being assessed, and then once it is done, they will calculate now how much of extra lightings they have to put now. So now they will start analyzing the energy part of it. So how much of energy it is going to, how much of energy it needs to run the building. Next. Structural system also, you have to create since when you're going with more a non-traditional form of design. So you're going to have a very unique piece, means even all the structural joints you have to make of your own. So every structural units will be different. Every structural, the molds for every structural units will be different. So you have to manufacture the molds, you have to manufacture each and every structural units also. So if you are going to have a unique solution, unique problem means the solution should also be unique, right? So this is an overview 3D model, I guess they have made. So this is some simple form, unique form which is being made. So in the last one, that when I mentioned how robots is being used in the industry. So it's not too far also. Europe has been already used, is been using robotic fabrications and construction in past decade. So India is also started using it. So I guess last 2-3 years it's been used in a very largest. So it's slowly coming into commercial field also. I'll just show you an example where it has been used commercially. I guess this is in Europe only some part. Totally 3D printed using clay, a residence is made. So it's it's the similar technique has been used for any type of 3D printing which we do in our conventional style. So you can see a bigger frame here in the backside. So this is our extruder where they are going to print it. So this is the form. So what they do is they assemble the printers first, then within that form. So within a day span, you can see you're raising a single block. So if you are going with more precast or fabrication techniques which are conventional style you are doing in current market, I guess that will be cheaper maybe. But how much is it going to affect the environment sort of? Let's say how this is going to affect the environment. So since this is made in clay and more the materials which is being used in the site only. So now what happens is you're reducing the energy which the building consumes, and now it can adopt to higher degrees also. So what temperature it can withstand more degrees now. So the materials which are used also is more native now. So now once this is made, I guess they made one more project also in here, you can see. So this is the printer which helped to made to print this building. So you can see a very larger printer. There is this one. So they pump in those. So this is one more residential unit which they made. So you can see this whole building, what they are going to make is under $1,000. So which is less than an iPhone. So when you are going to make some residential units, which is going to cost you in very maybe some less than a lakh or something, the affordability range becomes a lot. I'm not saying the R&D which they have put and the amount of money they have put to make the robot and everything, that will be in a very higher range. So what as a designers, what we have to look into is what kind of materials we are going to use, how much creative solutions we can give with the available needs. That's all. So that is what we have to look on. So now you can see the thickness of the building, which is not if you are going with a regular stone wall or brick wall, it will be more than 2 feet or 1 feet. So when you're going with a more solid wall, what effect that will give? So how much of radiation it can absorb or something. Now when you're printing with some gaps in between them, now they will start giving you an insulation effect and a more acoustical effect also. So now it will start creating. It's not what they do is it mimics some natural elements. That's all. You create some gaps between them. So now these gaps can be act as your to hide your ducts. So it will serve your functional purpose. Plus, since there is air pockets are there, it will reduce the radiation getting inside the building also. Already the material will have some inbuilt natural quality to absorb the radiation. Plus, these air gaps will gaps will reduce it even more. So now you're passing through different layers of transition here. So now this building will cost you much lesser running cost. Let's say now the wind will be more good. So amount of radiation you get inside will be less. You don't have to go for a more HVAC system or something. So how it structurally stands and everything. So all this is, so you can see it's been done in again some 200 hours or something. So within a span of some within a span of a month or something, they completely done with this building, which is completely done in clay again. So and that too under $1,000. So which is again less than maybe some 80 to 90K, which is I guess, let's say when did this video come? 3 years ago. Now it will be more or less, maybe some 30 to 40K we can. So basically it's what kind of material, that just the material cost, that's all. So whatever material, and that too if it is available locally. So the same clay and mud is what is being used, and then they are giving for a strength, they are mixing the cement. So that's all. So how this material reacts with one another. So you have to identify the material first, what kind of material is being traditionally used in the say. So maybe the same material is being used for plastering the inner around areas, but whatever you can make the whole building with this material. So once you start, working with different disciplines and knowing, what and all is the possibility, you can create your own solutions more. So I guess you can see So there are some forms which I made also, which I printed also. You can. So once we see here, yeah, the infills which they so the patterns you see between the walls, they call it as infills. So the infills which you use between the walls determines your insulations and acoustics forms. So this you can control your infills also, or how much of radiation effect you want to reduce. All those things you can do all those things in your design process only. And just a small furniture sort of, if you see this one, so how much of strength you're going to give, how much of flexibility you're going to give between all these materials, how much this material can actually take the load system. So you're going to design everything from the basic, and then how it reacts to the parameters. So it's just the form doesn't naturally come. You have to start experimenting with the forms, and then you have to you'll so I guess you have the freedom of experimenting now more. So you're not restricted with the software skill. Now you can whatever you're planning to do in softwares, you can always recreate everything with the current generations using 3D printers, CNC, milling machines, and everything. So you don't. So all these things, it comes into a package sort of. You don't have to learn for 3D printing a different software, CNC milling a different software. Sorry. Different software, and handling robots, different software, handling BIMs for a different software. Everything is being combined into a single package when you're learning in Grasshopper. So you just need to know how to basically code and code. That's all. You have a steep learning curve, but it's not necessarily to know everything. So you can always upgrade yourself. So this is what this course offers you also. So know what is in the market first. So once in the it's all been made, so now you can start creating your own experimental buildings also. So you can have you can still have your own style of design, but how you are going to scale it, that is what you can see I guess in this course. So once all these things are made, so I guess you can see. Yeah. Oh, sure. So the aesthetic doesn't means you have to have a different sort of interior elements there, different sort of paints and everything. So how the aesthetics are different, it depends upon different person to person and architect to architects also. So you can see here the type of printers also different for each type of buildings. So here you can see two types of printers printing at the same time for this module. And for this module, you have a single assembly printer, clay printer. So it doesn't matter what kind of printer again we use. All the all the system or robots work in a single code based system. So all those things, when you start learning the basic code, how things works, then everything totally depends now totally depends upon how you're efficiently designing that software. And here, I guess you can see each and every layer, how each and every layer has been printed in within this manufacturing unit. So what they do is it's again a more precast system based sort of only. Either you can print in your factory or something, and then they bring it to the system, bring it to the site, or what they do is they directly bring the printer to the site, and then whatever materials has been availably used, they feed it into it. So here you can see the person is actually adjusting all the infills, whatever he is doing in Rhino and Grasshopper simultaneously. So what they do is they don't hire masons or anybody, skilled persons to build the building there. Your architect is the person who's building actually. The printer is just, helping to print. It's not like a whatever robot they are using. So you can see here the person is actually adjusting the infills inside it and how much of wall thickness he is going to give. So everything is being made predetermined within the software scale only, and he's totally in control on what the printer has to print also. So you can see they have their own different types of they have their own different form variations of same model. So you have to experiment by in a very human scale or digital scale. You can create an exact one-to-one digital twin, but still, when you're making a physical model and then relating that to a natural scale, that will have some at least some 5 to 10% variation. So it is always best to create a digital physical model and then check what is is our actual data we are getting from the system, is it matching with the physical model. So you can always recheck everything. So once that is done, you can create your own type of iteration. You can create your own forms. You can create, you're not restricted now to any sort of parameters now. So if the location is not accessible, send robots to print it directly. If the construction is not possible, what you can do, you can make it precast sort of inside a building, and then you can just ship it to your construction site. And what kind of material you're using again. So it goes with your sustainability factor again. How this material, whether this material is going to sustain in your design. So if you're going to use the native and traditional system, so it has to be blend with the modern type, and then the future type, and then your traditional way. So it's not always more futuristic thought, and it is never. It will be just in software, and it is never going to happen. It's not. People started using it, and every time we just need to upgrade ourselves and think the possibility of it, know the industry and how it is being used, and all. Not everything is being restricted now. Everybody is now have an access about internet, AI, and everything. So you can learn everything now. I guess this course is really good course also. So once you're comfortable and you're ready to have the exposure about how to know the more advanced techniques about what is happening in the industry, I guess this will help you a lot. Okay. So this is almost we can see. So I guess once you're into the so once you guys are into the course and everything, so it's everything is been since it's been all displayed students only the first years. So the more upcoming batch we'll also try to have more new problems, more creative problems, and then how to tackle all the solutions we can see. Okay.
Thank you so much, Yokes sir, for having taken us through entire part of parametrism, all those. Thank you so much. Now we'll be having the concluding session. We'll be having the concluding session.
We have a query in the chat box. Please address it.
Just 1 second. I have just put a memo in the chat box. All the participants, please send in your names for the certificates. And for admissions also inquiry, the number has been given. The floor is actually set up for Q&A. Anybody has any questions, you can engage with any of the people out here. Okay, we have a question. I'm sorry, I just have to, there's a question from one of the participants. For Yokes, sir, what is the answer for multi-level, that is slabs in between? Yokes, sir, there was a question from Hemashri. So she's asking us, what is the answer for the multi-level IE slabs in between?
So that's what currently in industry, how printing works is it is possible to print in very higher scale, but since it's all in the experimental stage. It's 3D printing is been approved till maybe 1 or 2 levels. That's all. So when you're going for more structural based system, what they do is still it's been standardized to follow or frame the system only. So what you do is you build your frame network, which is our typical RCC walls and slabs and everything, whatever traditional using a traditional method, you make the scaffoldings and make. So again, the walls and everything will be printed in whatever materials you're using. So the framework will stand separately. Then the rest walls will happen like a curtain wall system. That's all.
Do we have any more questions? You can please put it in the chat box. Okay, so I'm going to bring it to the conclusion. Please do, to all the participants who participated, please send in your names and email IDs to generate your participatory certificates. Okay, as we come to the close of today's enriching program, I extend heartfelt gratitude to all our distinguished speakers. Now, to conclude the day, I now invite Professor Ashley Shukur to deliver the vote of thanks.
Thank you, Asmi. Am I audible?
Yes, please get it.
A very good afternoon to everyone. I am Architect Ashley, Assistant Professor here at Asian School of Architecture and Design Innovation. On behalf of Postgraduate Studies at Azadi, and on behalf of our Honorable Chairman, Architect B.R. Ajit, I am here to thank all of you who have made today's real-time class on advanced architecture a meaningful and enriching experience. First of all, I'm proud to say that all the 3 experts who spoke today are none outside our department, but are the experts who are leading the 3 semesters in the Advanced Architecture program here at Azadi. First and foremost, we extend our sincere thanks to our keynote speaker, Dr. Architect G. Shankar, for his inspiring address on sustainability in architecture and for guiding us at the semester 1 of Advanced Architecture program here, which is themed at sustainability in architecture. A special note of thanks to Architect Girish Ravikumar for leading the session on building information modeling and for challenging conventions in the design process. I must say that he is also leading the semester 3 of M.Arch program here at Azadi, which is themed in advanced building information modeling, construction management, etc. We also thank Architect Yokes Marapa for his engaging session on parametric design in architecture, and also thank him for making our students of batch 1 experts in parametric design, as you have seen in their presentation. I must thank the batch 1 students of M.Arch for their contentful presentation and for setting a good example for the coming batches. We would like to express our gratitude to our principal, Architect Shankar Gargade, and also to Architect V. and Ramachandran, Head of M.Arch Department, for their active involvement and mentoring throughout the event. We would like to thank Vice Principal, Architect Anita Menedar, and Architect Vashni Livingston for constant guidance and support. We also extend our appreciation to Architect Kuku Joseph and Architect Adul for their efficient organization and tireless effort in making this event a success. A word of appreciation to our technical support team, Architect Madhu, Architect Roshan, Mr. Sagar, and Mr. Rajendran for ensuring the seamless conduct of the online event. Architect Shibli, Architect Dhanush, and Architect Ashish for facilitating the session recording and streaming. Thanking Architect Abarna for coordinating the in-person attendees. Huge thanks to Baxton students for volunteering the entire session. Our heartfelt thanks to all faculty members, non-teaching staff, and students whose cooperation and participation added great value to today's program. Special thanks to Architect Asmi Shahjahan, our M.Arch Batchman student, for expertly moderating today's event. Finally, thank you to all our guests and participants for being with us today, for your enthusiasm, and for contributing to the spirit of learning and innovation that this event stands for. Thank you all once again. Over to you, Asmi.
Thank you, everybody, for having. We've had a great session from morning to now, so I would like to sign off right now. In future, we might have more sessions. Thank you.